So this is the model that we have created in the last session. I mean, we have completed the modeling and analysis part. The only thing that is left over is the design part. That is what we were talking. So before doing the design, let me show you a couple of things here. So just click on 3D view. So you can see said square footing with a column, the vertical column you can see. Suppose if you want to see the loads, so how will you see the load? So just go to display, and here you can see there is an option called show loads. So click on show loads, and here what is the type of load that we have applied? It's a live load, not dead load, it's a live load. So select the live load, and then it's a point load. So select point load, and then click on show loading values. What will happen when you click on this is it will show the value also, how much amount of load that is being applied on the
Sir,
system. So just click on that. Yeah.
excuse, excuse me, sir. I
Yes,
guess the
yes.
screen got stuck. Sorry, it's not showing what you're saying.
Sorry, the voice is not audible properly.
Um, I think the screen got stuck. Sorry, actually, the screen is not showing what you're saying. Those
Oh, okay,
options and
okay,
all
okay,
are not visible.
okay. Just give me a second. I'll just stop my screen sharing and I'll restart it. So just click on the 3D model so that you will see the 3D model of the element that we have modeled. So now, if you want to see the loading, so how much amount of load that is being applied on this. So just go to display, just click on display here in the menu bar, and then click on show loads. So basically we have applied a live load. So just click on select the live load from the drop down, and it's basically a point load. So select point load, and if you click here, that is show loading values. What does it mean? Is it will show the value, that is how much amount of load is being applied on the column member. So just check this one and then click OK. Right. Now you can see there is a load of 1400 kilonewtons that is applied on the section. Now, what we need to do is we were looking for the design part. If you remember, in the last session, we have seen the three different things. One is we have seen the checks against the soil, upward soil pressure. I have also shown you how to look after the settlement. And then I have also showed you how to look after the punching shear. Basically, it's a two-way shear. Now, with this part, the analysis is completed. Okay, with this part, the analysis is completed. Now, what is left over? The leftover is design process. Okay, the leftover is design process. Now, what we are going to do in the design, before that, what we need to do is we need to check the moments. Okay, we need to check the moments and percentage of reinforcement. So these are the two important things. So check moments and percentage of reinforcement. Only then it will be available. So we need to check for the moments and percentage of reinforcement. Now, how to check this one? So basically, there are two methods or two approaches, you can say. There are two approaches that are available for the design of, okay, for the design of elements in CSI safe software. What are they? So there are basically two approaches available for the design of elements in CSI safe software, especially the footing or foundation slab. So the first method is called as strip-based method. The first one is called as a strip-based method, and the second one is called as finite element method, FEM. Okay, finite element method. Now, which one we need to use, especially when we are designing foundations for any type of footing, for any type of structure? Which one we are going to select, either the strip-based method or finite element-based method? What I personally suggest, based on my experiences, it is always advised to go for the strip-based method. It is basically, you can say it as a conventional method. What is the reason for that? The reason is in finite element methods, you should be very good at finite element methods concept. So if you know finite element methods concept, then you can use this software, that is CSICF software, to do the modeling and the design and analysis part of it, any foundation structure. But since we will not be so good at finite element methods at this level. So whatever is your graduation level, maybe third year or fourth year, so you will not be good at finite element methods. You might be knowing, but only the fundamental concepts you will be knowing. So not at a deeper level. So what I will prefer is, I will prefer you to go for a strip-based method. Okay, we will use basically the strip-based method for the design. Now, whatever the analysis that we are going to do from now on, all those analysis we will be doing which is based on strip-based method. Now, what we have done here, if you see this modeling part, we don't know whether we have done this modeling using strip-based method or finite element-based method. So I have not used any special methods for modeling. If you have followed the previous sessions, I have not said anything about the strip-based method or finite element-based method. Why? The reason is here my intention is to show you how to model the column and how to model the foundation slab and how to check for the upward soil pressure, the punching shear and settlement. That's my motto as of now. So now what we are going to do is we need to do the strip-based method design. Okay, we need to do the strip-based method design. Now, how will we do that? So in order to do the strip-based method design, just unlock the model. You can see there is this option here in the top quick access bar, unlock the model. So just click on that unlocking the model. What will happen when you unlock the model? All the analysis or the whatever the things that you have done so far, all those things will go away. The results part will go away. The modeling, everything will be the same. Only the results part will go away. So just click on unlocking the model. So remember, whenever you want to do any changes in the model, first you have to do the unlock. Okay, you need to do the unlocking of model, right? So just select OK so that it will get deleted, right? So now what we need to do, we need to do the strip-based method design. So let's draw the design strip. So how to draw the design strip? So in order to draw the design strip, we have this option here. You can see in the left quick access bar, there is this option which is called as draw design strips. Let me keep the cursor there. You can check down. You can see draw design strips. So this is the option that we need to use in order to do the strip-based method. Right. So this is where one option is. The same option you can also find in draw. You can see there is this option called draw design strips. Okay, anyway you can use. Right. So let me go with this option, draw design strip. So just click on this. Now here you can see it is asking you a couple of instructions. So how to draw the design strips. Now in order to draw the design strips, we will have two strip layers. Okay, we will have two strip layers. Now the first thing that we need to know is what does it mean by strip? I'm telling it's a strip based method and all. What actually is a strip? Suppose if you take a footing. Okay, if you take a footing, in the last session, if you remember, I told you that the cracks will form in the foundation somewhere in a 45 degrees angle. Like this, the cracks will form. Now, what I told that this particular portion, okay, whatever this portion is there, this portion is a strong portion. Okay, this portion is a strong portion. Which is the weaker section? The weaker sections are these cantilever elements. Okay, whatever this cantilever portion that you are seeing here, this portion is basically a weaker portion. Why? Because cracks are forming at an angle of 45 degrees. So this portion and this portion will separate from this entire structure or this entire member. So for that reason, what we need to do is we need to do the strip-based method. Now, for every time, whenever you are doing the strip-based method, we have to follow some conventions. Okay, we have to follow some conventions. Suppose if this is your if this is your foundation slab and somewhere here is your column. Okay, so we will have two strip layers. You can see here in the dialog box a strip layer A. So strip layer A and B, two strip layers will be there. Now, whatever the layer that you see along the length of the footing, okay, whatever the layer that you see along the length of the footing, that I'll call it as a strip layer A. Okay, the length along the length of the footing, the strip layer is A, and along the width of the footing, the strip layer will be B. Remember these things. So along the length, the strip layer is called as A, and along the width, the strip layer is called as B. So you need to define these things. So strip layer A and strip layer B. Remember that. Along length, okay, along length is strip layer A, and along width is a strip layer B. Right. So now remember this convention. So you should not forget this one, because from now on we'll use these ones only. Right. So now we need to select these ones. So here let me select these options. So strip layer is A. So first let us design it along A, and then I'll design it along B also. So let me design strip layer as A and strip design type. So basically we are designing a column strip. Okay, we are designing a column strip. Now here we need to give the start width left, start width right, end width left, and end width right. What are all these things? We know the width of the footing. So in this case, it's a square footing. So there is no problem. On all sides, it is same, which is 2.8 meters. Okay, that's the area, that's the size dimension of our footing. So here, start width left, right, end width left, right will become whatever is the size of the footing. Okay, or whatever is the dimension of the footing, that dimension divided by 2. Okay, that dimension divided by 2 will be the values that you have to give here. Okay, will be the values that you have to give in all these 4 elements. So it will be 2.8 upon 4 upon 2 is 1.4 meters. So we should give 1.4 meters in all these elements. So it is basically the half of dimension of the footing. Okay, half of dimension of the footing. Now you might have a question, what if it is a rectangular footing? What we have to do? So we'll see that when we are discussing about rectangular isolated footing. Okay, that I'll talk in the next session. Okay, so right, so I have given these elements. Right, so now what we have to do is, so we have defined all these things. Now we have to give the strip layer. Okay, now we have to give the strip layer. So how to give the strip layer? So currently, what is our strip layer I have selected? It is A. Okay, it is A. Right. So now A is along what? A is along length of the footing. Somewhere here, the length of the footing. So how to draw the strip layer? So we will use this particular option to draw the strip layer. You can see in the left pane. Right. So now once you have selected all these elements, just click at the center of the strip layer is along A, right? So we need to draw the line in this way. Okay, we need to draw the line in this way. So just move your cursor. Okay, just move your cursor so that you will see the midpoint. You can see there is a midpoint here. So just click there and then freely move to the other end of the or other side of the footing. Okay, and then make sure the other side also it should match with the midpoint. So now once you see that midpoint on the other side also, just click it. Now once you click, you will see a pink line. But if you move your cursor, you can still see the command is in the active mode. So how to deactivate the command? In order to deactivate the command, just give right click. Okay, right click, done. So now what we have drawn the strip layer along the length. Now we need to draw the strip layer along width. So along this line also we have to draw. So in order to draw the strip layer along width, here we have to change the strip layer as B. Okay, here we have to change the strip layer as B. So select the strip layer as a B. Right. So once you select the strip layer as B, we are designing a column strip and the dimensions are also same since it's a square footing. So there is no problem. So once you complete this one, then move your cursor to the center point of the along the width. So you can see the center midpoint here. So I'll just zoom out. You can see there is a midpoint here. Just click on that and then freely move to the other end. And then once you find the midpoint, just click it there. Now also you will see one more pink color line. So that means we have designed the strips or we have modeled the strips along the length and along the width. Why we are doing all these things? Because we need to do the reinforcement design. So in order to do the reinforcement design, this is mandatory factor, right? So now in order to disable the command, just right click so that the command will get disabled, right? So with this, what we have done, we have completed the modeling of strips, or this is how you can say the defining the strips, right? So just once after this is done, so just let me click on select object so that command will be deactivated, right? So now if you want to see the strips in a beautiful way, there is one option which is called as, you can see on the top, that is this one, okay, the tick bar. So just click on that, set display options, and then here you can see there is one option which is called as extrude view. Here in the options, you can see there is this option called extrude view. So check this one. Okay, check this extrude view option. Or you can also do it in another way. So let me show you that the other way also. Extrude view, I'll tell you in some time. So the other option that we need to look after is we need to look for design strip, right? Here you can see design strip object. Now, if you want to see the width of the strip, there is this option, you can see show width. Okay, click on this option, show width. So check this option and then click OK. Okay, and then click OK. Now, actually, you don't see any difference. You can see some lines has come, but you don't see what is actually the strip. Now, if you give some extra dimension, then you will be able to see that. Let me show you that. So just right click on any strip line. Okay, right click on any strip line. Suppose, let's say I'm selecting the horizontal strip line. So just keep the cursor. So if you want, you can zoom it, keep the cursor there, and then right click. Once you give right click, just change the dimensions. So go to geometry. In the geometry, instead of 1.4, let me give it as 1.8. Okay, let me give 1.8 for all the sections so that you will see the strip. Right. So click OK and then click OK. Now you see the strip has come outside of the plane. So this is actually the strip. So this strip, how long it should be there? It should be covering within the footing only. Okay, it should not go beyond the footing width. It should be there within the footing. So make sure of that one also while designing it. So how to change that? Just keep the cursor on any strip line, either along horizontal or strip layer A or strip layer B. Just right click and then here change the dimensions. So what should be the dimensions? Half of the width of the footing. The total width of the footing is 2.8. So change it to half, that is 1.4 meters. So just give it as OK, and then click OK. Now you can see. Right. So now what we will do is, if you want to check the property of strip, okay, let's say I want to check the property of strip. So for that, what we have to do is just right click on any strip. Okay, right click on any strip. So let me select the horizontal strip first. So just keep the cursor there and then right click on it. Right. Once you do this one, you can see there is this option called assignments. So you can see which tab it belongs to or which group it belongs to. So this is not a bothering factor. And then geometry, you can see the dimensions, all these points. That is also fine. Now this is where we need to bother about design tab. In the design tab, if you see the options here, what is strip layer that we are looking for? A. So what is strip layer A? It's a along length. So that's also fine. So strip design type. So we are basically designing the column strip. That is also fine. Design this strip. Yes, we are looking to design the strip. Ignore PT for design. PT means pre-stressing and post-tensioning. So that we don't need to bother. So let it be no only. Now, this is something that we need to focus on. Rebar material. What is our rebar material? Our rebar material is Fe415 grade of steel. Okay, our rebar material is Fe415 grade of steel. So here we have to change this steel. Okay, make sure of this one. We have to change this grade of steel. So how to change that one? Just click on that. A dialog box will pop up. Okay, so we need to select the strip layer A. We are designing the column strip and then design this strip. So that's couple of options. And then here you can see ignore PT when designing this strip. So you can select that option also. That's not a problem. Okay, so ignore PT while designing this strip, and then you can see from preferences, and this is where we need to look for rebar material. Okay, rebar material. What is our rebar material? Fe415. So click on this drop down and select the grade of steel that we are using. Okay, and then click OK and OK. Now we have changed the material for along the strip layer A. Now we need to do the same thing along strip layer B also. So just keep the cursor on the strip layer B, right click, and then go to design, check all these things. Now we need to change the rebar material. So click on this option and then here select the Fe415 grade of steel and then click OK. OK. Right. So this is done. Right. So now just go to design. Okay, go to design. In the design, we can see this option called design preferences. Let us check whether whatever the dimensions, whatever the cover, the code, all these things are perfectly fine or not before doing the analysis part. Right. So let me click on design preferences. You can see the code, design code is IS456, no problem. Steel and then concrete factor of safeties, and then cover to the slabs. Cover is clear cover top is 50, bottom is also 50. So that is also fine. And then anything else, if you want to check, you can just have a look into all these things, right? So preferred bar size is 8 mm only because we need to take half of the layer, half of the diameter of bar, right? Once you select all these things, just go to minimum cover Okay, minimum cover in beams. So here also we need to, basically beams we are not going to bother, so let it be like this. So we'll bother about this option when we are designing the strip beam or strip foundation or strap beam or strap foundation, whatever you can call. And pre-stress or post-tensioning, nothing is required. Just click OK. Okay, but minimum cover slabs should be checked, which is 50 mm. That is fine. So let me click OK. Now we will do the analysis part. So just click on Run Analysis here. Now the analysis gets completed. So once analysis is done, okay, once analysis is done, now we need to look for the upward soil pressure, all these options, upward soil pressure, and then settlements, and then punching shear, all these things. So let me check the upward soil pressure. So how to check upward soil pressure? There is this option here. Okay, this is upward soil pressure check. So click on this one, right? So load combination. So basically we are looking for dead load plus live load combination. So we are going to apply the soil pressure. Select this option, display contours automatic. Let these things be default. Click apply and then close it. Okay. Now, if you move the cursor, you can see the upward soil pressure is 197.71. That is the same value that we have got in the last session also. Okay, if you have a doubt, just refer to the previous session video. So that's the same value, right? So now the next thing is, let us look at the settlements. Okay, so how to look for the settlement? What is the option? You can see this option here. Okay, so this is our settlements option. Sorry, not this one, the other one. This one. This is our settlements option. So let us look at the settlement. So just click on this option, show deformed shape. Okay, so click on this option and load combination. We need to select the load combination as dead load, live load, automatic, draw contours, let all these be same, apply, close. Now, if you keep the cursor at the center, the value is minus 24.71. What is the allowable settlement? 25. Maximum settlement is 25. How much we are having? Minus 24.71. So it is within the limits only. So there is no problem. Right. Now, the next thing is we need to check for the punching shear. So what is the option that we need to check for punching shear? So this is the option. Okay, this is the option. So click on this option, which is called as show punching shear design. Click on that and you can see the value at the center, which is punching shear value 0.487. This is also the same value that we saw in the last session also. Now, how to know whether punching shear is safe or not? If the punching shear value is less than 1, then the value is safe. Okay, whatever you footing that you have designed, that is safe. Right. So now what we will do is, let us keep the cursor at the center of the point or center of the column. So, and then right click. Okay, right click and make sure to check the code book is appropriate or not. And what is the other thing that we have to check? The column look. The load combination. The bending moment diagrams. Okay, let us see the bending moment diagram. So just let me close this one. Right. So in order to see the bending moment diagram, we have this option which is called as show strip design. Okay, this option is called as not design forces, I think. Show strip forces. Yeah, show strip forces. So just click on that so that you will see the bending moment diagram. Or this option you can also find it out in display. Check display, and then this option called show strip forces. You can see here. Right. Anything you can click. So click on this one, the load combination. So we have to select factored load combination. Remember, bending moment shear forces, we always do it for factored loads, not the service loads. So select the factored loads, that is 1.5 dead load, live load, and then component. So we need to look for the moment. So let's check the moment and whichever layer you want to see. Suppose if you want to see the moment along only layer A, then you can select layer A. If you want to see the moment along layer B also, then you can select both as well. First, let me show you for layer A, then we'll see for layer B individually. Okay, so that you'll understand what I mean. So select layer A. So we are going to see the moment along strip layer A. That is what layer A represents. Okay, so check fill diagram, show values also you can check to see the bending moment value. Now click apply, and if If you move this one, you can see the value. What is the moment value here? I think you can read it, or you can check it out. 728.86. Okay, that is exactly at the center. Okay, 728.86 is exactly at the center. Right. But in manual calculation, let us look at the manual calculation. Let us validate whether the moment is same or not. So for that, let me check the moment. Where is the moment? Right. So here you can see what is the moment that we have got. We have got 594. Okay, in manual calculation, the moment along X and moment along Y is 594. But how much we are getting here? 728. It's almost 300. I mean, we got some 128, 140 extra value is coming. Okay, why this difference is coming? The reason is in the safe software, the moment is calculated always from center of the section. Okay, in safe software, the moment is always calculated at the center of the section. Now, if you want to know the moment, but in manual calculation, how we have calculated? We have always calculated the moment from face of the column. Okay, in manual approach, we have calculated moment from face of the column. So that's why we have taken this 1/2. Okay, 2.8 is the total length of the footing. We have divided it to half, that's 1/2. Okay, so in manual approach, we have calculated the moment from face of the column, but in CSI safe software, the moment will be calculated at the center. Okay, the moment will be calculated at the center. Right. So if you remember in the last session, okay, if you remember in the last session, I told that at a particular portion, what is that portion is, suppose, let me draw this one. Right. So at this particular portion, okay, the cracks will get initiated at a 45-degree angle. Okay, so here the column will be stiff enough to resist the loads. So this portion will be very stiff to resist the loads. Why it is very stiff to resist the loads? Because the load will be coming from the column and the reaction forces will be at the bottom. But when you look at the sides, I mean this cantilever portion and this cantilever portion, do we have any loads coming from the top? No, there are no loads. So here we have the loads that are coming only from the bottom. What is the load that is coming from the bottom? Upward soil pressure. So in the cantilever portion, we have the non-equal distribution of forces. Okay, we don't have the equal and opposite reactions. We have only the reaction forces. We don't have the action forces that are coming down. So for that reason, these cantilever portions are always in danger. So that is why I told that these portions will always have a chance to get failed, but this portion will never get failed. Why? Because we have an action force and we have a reaction force. So these two will get cancelled and this portion will be very stiff. There won't be any problem with the central portion. The only problem comes here is the cantilever portion. Okay, the only problem comes here is the cantilever portion. Right. So now, if you look at the manual calculation, so I told that manual calculation is done at a distance d from face of the column. Okay, at a distance d, from face of the column, the moment is calculated. But in CSI safe software, the moment is calculated at the center. Now, if you want to know the moment at face of the column, just move your cursor. You can see, move the cursor to the face of the column. Now you can see at the bottom. Okay, you can see at the bottom. See, when I move the cursor, you can see the values are getting changed. Can you see the values at the bottom portion of the footing? Okay, so that the bottom line of the footing you can say. So what is the value? What is the value? 591.6694. That's the moment at face of the column. What is the value that we get in the manual calculation? It is 594. What is the value that we face of the column? It is 591.6. It's almost 592. So that is almost close. Safe software and Excel manual calculation. That's how you can validate the result. So don't think that I'm getting here 728 and here I'm in the math I got 594. No, it's not correct. In manual calculation, we have calculated from face of the column. In safe software, this value represents it's the center of the center of the column. Now, if you want to see the moment at face of the column, just move your cursor at any face. You can move to any face, no problem. So at either faces, it will be the same. There won't be any change in the values. Okay, minor changes will be there, but that's not a problem. So that's how you can check for the moments at base of the column and also at center of the column. Suppose if you want to see movement at any other, so you just move the cursor, you can see the moment that is getting seen. Now, when you come to the farther end of the strip, when you come to the farther end of the foundation slab, can you see the moment got reducing? See, at center, the value is 728. Now, when you move to the edge of the footing, what is happening to the what is happening to the moment? It is getting reduced. That means whenever maximum load is being applied at the center, the moment will also be maximum wherever the load is getting applied. When you go away from the load application, the moment intensity also getting reduced. You can see the maximum moment is here. When you go away from the center, the moment is getting reduced. That's what this diagram talks about. Okay, so that's how the moment is getting applied. So we have got to know the moments also. Right. Now, the next thing is, let me close this one. Now, the next thing is, let us do the strip-based design. Okay, let's do the strip-based design. So before that, let me show you a couple of other options. So just go to display. In the display, there is this option called show slab design. Okay, click on this option, show slab, and here you can see the design basis. On what basis you want to design this particular footing. To design based on strip-based method. You also find finite element methods. Click on this drop. Can you see finite element based method? So we will be focusing on strip-based method. So select that strip-based method design and then display type. Let this be the enveloping flexural reinforcement because we need to provide the flexural reinforcement. Wherever tension happens, we are going to provide the reinforcement in the concrete section to take care of the bendings, right, or flexure, right. Here, this is enveloping flexural reinforcement, and here we will see the reinforcement later. Okay, we'll talk about the shear reinforcement. If you click on this drop down, you can see shear reinforcement. We'll talk about shear reinforcement later. What reinforcement? Shear reinforcement is nothing but in beams we will provide the shear reinforcement in the form of stirrups. Okay, this is in terms of beams. In columns, we will provide in terms of lat. I hope you remember this. Okay, in beams, we'll more stirrups. In columns, we'll provide in the form of lateral ties. So we'll talk about shear in later cases. Right. Currently, let it be the same one. Right. Now here you can see impose minimum shear reinforcement. Impose minimum reinforcement. What is the minimum reinforcement? AST minimum value. The value 0.12% BD. So minimum reinforcement is 0.12% BD. So we need to impose that minimum reinforcement. So we going to tell to the safe software that minimum to minimum, you have to provide this much amount of reinforcement. If you don't check this option, then it will not consider the AS456 code provision. That is this one, it will not consider. So you should always provide minimum reinforcement also. Okay, check this option, impose minimum reinforcing. Where in annual design, some cases we have got. So when we are calculating AST, sometimes we have got the in some designs we have got the AST as let's say some 800 mm square. But when we are the minimum reinforcement, that is AST minimum, we have got the AST minimum something like this 900. So in that case, which reinforcement do you have to provide? We have to provide this reinforcement, not this one. Minimum you have to provide this one. So when you this particular greater value, that it will provide. If you don't check this option, then it will provide whatever calculate. So make sure of that. That's the idea, right? So check impose minimum reinforcement, reinforcing, and then here you can see top bar. So we'll provide only the top bars. We don't need to for the bottom reinforcement. Okay, bottom reinforcement, however, we'll provide. But if you want to see both, you can check both, no problem. But remember, in real time, we have to provide both the top reinforcement bar and bottom reinforcement bar also. Right. So for currently, let us top bars only. Bottom bars you can check later and then we'll check. Okay. So top reinforcement bar. Let's say we will see only the bottom reinforcement, the top reinforcement. Okay. So just check show bottom rebar and then uncheck the show top rebar. And here reinforcement display type. How you want to see the reinforcement? You can see based on three categories, you can check the reinforcement part. One is show intensity, that means per area per unit width it will give. That means in terms of mm square it will give. Okay, and here show total rebar area strip. So if you select this option, it will show the total area of steel. And here this option, it will show only the number of bars of specific size. Whichever size that you select, it will show for that size. Right. So currently we will be looking up this one because we will always check for total reinforcement. So that's why we'll go for this option. So let me check this option, show total area or show total rebar area strip. Okay, check this option. And then we need to select strip layer. So here you can see strip direction. So first we will look for layer A and then we'll look for B. Okay. So check layer A. Okay. And then display options. So let it be fill diagrams and also let us also see the values. So check show values and then show rebar above specified value. So if you select it as none or typical uniform reinforcement space specified below, we'll check these two options in the later cases. For other designs, try to check all the options in one design itself. So select this one and then make sure of selecting these two options also and then click apply and then don't close this dialog box. Let it be like this. We will see later. Here you can see reinforcement. Can you see the reinforcement provision? If I move the cursor at center, is the reinforcement at center? Can anybody tell? What is the reinforcement value that you are getting at the center? It is 4348.67 mm square. Away from the center. Can you see the reinforcement value is being decreased? Why? Because maximum bending is happening at the center. So since maximum bending is happening at the center, you need to provide more reinforcement here. And when you come away from the center, there is no much load. So reinforcement value will get reduced. You don't need to provide too much of reinforcement. You can see there. Right. So that's how we can design the reinforcement or we can provide the reinforcement. Okay, you can see at center the value is 4368. Right. At face of the column, what is at the face of the column? 3683. But let us check in the same thing in manual calculation also. What is the AST value that we have got? What is that? AST type 3174 mm square. So this is the value that is obtained at manual calculation. Don't confuse with this one. This is reinforcement at center. We have calculated reinforcement at face of the column. You can see what is the face of the column reinforcement? 3683. Okay, but how much we have got here? It is 3174. That's also fine. That's not a problem. Okay, so it's almost close. Though it is 500 mm square higher, but it can be considered. There won't be any problem. Right. So to know the reinforcement details, suppose let's say here if I move to every section, you can see the reinforcement value is getting changed. Now, to know the reinforcement details at each section, we cannot always move the cursor. Okay, it is not possible. We have to get the direct values. So how to see those direct values? So in order to know the reinforcement details at each section, we need to simplify the process. Let me show you that simplification process. Okay, so here, if you want to change it to layer B, you can change this one, click up, and you can see layer B also. So you can check that. So if you want to select C, click apply, you can see that. Right. So now what we need to look after is we need to simplify this design process. Why? Because every time we cannot move the cursor here and there and look for the value. So when you do the values or when you give the reinforcement values to the site engineer, he should not be able to move the cursor here and there because he will not have any laptop or software. So you should directly give the value. This is the amount of this is the area of reinforcement that you have to provide. How to do that? So to simplify that process, we need to do the strip-based design process. Let me show you what is that. Right. Let me show you how to do that. Before that, we need to unlock the model. Why we need to unlock the model? Whenever you want to do any changes in the model, you need to first unlock the model. Right. So just click on unlocking the model. Click on unlock. Okay. And then all the results and analysis will get deleted. Right. Now, what we will do is just select the entire model by dragging from left to right. Okay, just select the entire model. Why I'm selecting is instead of the same model, I will take a copy of this one, or I will duplicate this one, and then I'll do it. Okay. So select the entire model by dragging from left to right. Okay. If you want to clear the selection, just clear here and then drag it from left to right. Right. So once you do this one, if you want to replicate this one, however, we are not going to do in the replicated section. I'll show you separately how to do that. Okay. So I'll show you, I'll make a separate design model. Right. Select this one. So here you can see there is this option under edit, which is called as replicate. You can see here the shortcut also, you can see Control R. So click on replicate. It will ask you where it has to replicate. So let's say 3 meters, 3 meters. Okay. And then number of increments, how many replications you need. If you give 2, we can do, however, going to do is duplicate. So that understand what exactly we need to do that. That
Sir, your voice is currently breaking.
right. Sorry, there was some internet connectivity issue. I hope you are able to see the screen. Right.
No, sir,
Right.
screen is
So
not visible.
okay, let me stop my screen sharing and let me restart. Right. I hope now you are able to see.
Yes.
Yeah, fine. Thank you. Right. So now what we need to do is I'll be doing the first I have modeled the footing or foundation slab. Now let us model the column. So earlier what we have done, first I have modeled the footing and then I have modeled the slab. Now column. Now I don't want to model the column directly. I will model the strip area. So strip area along length direction, strip area along width direction. That's what I'm going to do now. So that's how you have to do in actual scenario, right? So let me, yeah. So now what we will do is, so now here I'm going to model the strip area. So let us do that. So why I'm doing it is because whatever the footing slab exactly under the column, that is basically stiff. So we need to bother about the other portions. That is, so what if this is the column and if this is the footing, this portion will be very stiff. So there won't be any problem with this portion. Now what we have to bother about, we have to bother about this portion. That's what I'm going to do. Okay. For that, what I am going to do is I am going to design this one so that automatically the software will give the design for the cantilever portions as well. That's what the concept here is. Okay, software will take care of that design. Right. So now what we will do is let's define the slab only for stiff portion under the column. So what is the stiff portion under the column? So the stiff portion under the column is this one. So this is basically the stiff portion under the column. Whatever the portion that is there exactly under the column, that's called a stiff portion. All right. So let us design this particular stiff portion, right? So for that, just go to define. In the define, we can see a slab properties. Just click on slab properties, and here select the slab, whatever that we have given. And here we should not select directly the slab. The reason is now we are defining the stiff area. Okay, we are defining the stiff area. So let us define that stiff area. So for that, what we have to do is we have to add the new property. So just click on add new property, and here the property name I'll give it as stiff. Okay, so and then slab material is basically M20 grade of concrete and type. Okay, so here we are not designing the slab. What we are designing? Stiff area. So select this one, and then here you can see the stiff area. Okay, this portion we are going to design. So select this one, and then thickness you can give any value. It will not bother about that. Okay, the stiff area thickness you can give any value. Randomly you can give some value. It will not have any impact on your design. Okay, make sure of that one. So you don't need to give exactly 200, any value you can give. So I'll just go with the default value, whichever that is there. Even if you change also, that doesn't matter. It will not influence our design part. So just click OK. So once you click OK and then click OK, right. So now what we have done, we have selected the stiff area. So now what we will do is we will select the center point. So that is quick draw areas around point. Select this option. Okay, so once you select this option here, what we need to do, we are going to design the slab. So select the type of object as slab, rectangular slab, property this one, and then here is something that we need to focus, property. So we are not designing the foundation. What we are designing? Stiff area. So click on this option, you can see stiff. So select the stiff, and here where we are designing the stiff from, in the column. So wherever column is there, if you remember the diagram, wherever the column is there, exactly under the column, we are going to design the stiff area. So how to find the dimension of the stiff area? The dimension of stiff area will be the dimension of the column. Whatever is the dimension of the column, that will be your dimension of the stiff area. So what is the dimension of the column? Let me check. I think it is 400. Right, 400 by 400 mm. So select give 400 in meters. That is 0.4 meters and 0.4 meters. That's the dimension of the stiff area. Give this one, trim at edges, let it be this one. Now just move the cursor to the center point. You can see the midpoint has been located. Now click it. Once you click, what you will get is you will see a small square, which is actually the column. Let me click on that. Right, can you see? It's a small square. That's basically the column. Now to assign the load at center of column, what I have to do, I need to have one point. That this midpoint I need to have. So let us draw that point also. So let me disable the command. And now in order to draw the point, why I need to draw the point? Because I should exactly place the load at the center of the column, right? So for that, I will define a point, center point. So instead of moving my cursor and checking down whether it is exact midpoint or not, and I'll just define a point. So how will you define a point? Just go to draw, and here you can see there is the option called draw points. So click on that, and here type of object is point. We don't need offsets, so let it be this one, and move the cursor to the center. You can see, and then click on the midpoint. Once you see the triangle box, then only you click it. Once you click that, you will see a plus mark, right? Can you see the plus mark? Right. So that's how you can make the midpoint. So now what we need to do is we need to apply the load. Okay, let us assign the load. So let me disable the command. Now how to assign the load at the center point in a column? For that, we have to apply this point, that is in this midpoint. So select this point by dragging from left to right. Make sure that in the drag portion, your midpoint has to get covered. Select that one. Now you can see at the bottom left side, one point selected. Right. So we have selected the point. Now you may ask, is it for column? I told that we have one top point and we have one bottom point. Is it the top point or a bottom point? It's actually only one point. I have not designed the column. I have defined only the point. That's it. Okay, remember that. But in the previous two sessions, first I have defined the column, and then I have went into 3D view, and then I have selected only the top point. That's what I have done. So now we don't need to do that. Right. So now let us assign the point load. So how to assign? Just go to assign, and here load data. In the load data, we are going to assign the point load. Select that, And here we are going to assign a live load. Okay, what is the total intensity of load? It is, let me check that. Yeah, 1400 kilonewtons. You can see here 1400 kilonewtons. Let me give 1400 kilonewtons, and then x dimension and y dimension. What is punching area? It's actually the dimension of the column, 400 by 400 mm. And you can select either replace existing loads or add to existing load, because we don't have any loads, so you can select anyone. So click OK. Now you can see the load has got applied. Okay, so now you can see a red circle that is coming. When you see the red circle, that means the load has been applied. Now let us see it in a 3D view. So just click on 3D. Let me, right, just click on 3D. These columns don't bother. These two, we are not going to bother about these two columns. Okay, this is our column, right? Now, but anyway, you can spot the difference. So here we have the column. Okay, here also we have the column. However, that's a duplicate, no problem. But here you see in this image, do we have a column? No, directly I'm applying the load at the center of the section, right? So that's what I have told you. So I have not designed the column. Instead, I have designed directly the midpoint, and then I have applied the load, right? So you can see the load of 1400 kilonewtons, right? So let's click on XY plane. So this is our one. Right. So let's click on XY plane, and now let's assign the soil subgrade property. That's the last one. So select the bigger square. Okay, that is the foundation slab. So I'm calling it as bigger slab because bigger square, because this is the foundation. So you can see at the bottom left side of the screen, one area, 4 edges selected. Make sure of that one. So select that one and then go to assign and support data soil properties. So select the SBC 200 at the rate 25 mm, click OK. Now you can see green color plus symbols that are coming around the perimeter of the foundation slab. That means SBC has been applied. Okay, and you can see the value here, right? So now the next thing is, let's draw the design strip. That is what we need to do now. Okay, design strip drawing is our parameter, is our important parameter, right? So let us draw the design strip. So how to draw the design strip? What is the element that we need to look for? This one. I told you again. I told you previously. Okay, this one. So let me select this option, which is called as a draw design strips. So click on this option. Okay, now you can see this dialog box that is popping out, and here for which type of object is strip and strip layer. So for which strip layer, let us draw first. We'll draw for strip layer A. So let me select strip layer A, and it's basically a column strip, and start with left, start with right, end with left, end with right. What is these ones? It is 1.4 only. How this 1.4 is coming? The total size of the column is 2.8 meters. 2.8 upon 2, that is 1.4. That's how this 1.4 is coming. We'll talk about rectangular footing in the upcoming sessions, how to change these values, right? So select these ones, right? So now what you have to do is strip layer along A. So how strip layer A will come? It is along the length of the footing. So we need to draw the strip layer. So how to draw? Just keep the cursor at midpoint of the vertical line. Okay, click on that and then freely move to the other end of the vertical line, and make sure once you notice the midpoint, just click there. Now you can see a pink color line that has come. Okay, a pink color line that has come, right? So that's strip layer A. Let me right click to disable the command. Now let us do for the strip layer B also. So strip layer B is actually, it is in the vertical, that is along the width. So here you need to change the strip layer. Okay, instead of A, you should go for B, and all the dimensions remain same. So now click on point at the midpoint of the horizontal line, any horizontal line, either top one or bottom one. Click on midpoint and then freely move your cursor to the other line or the opposite line, and then click it. And then right click to disable the command. Now you can see the strips have been modeled. Okay, the strips have been modeled, right? So now what we are going to do is, we need to look for the modeling of this strip design. Modeling of stripping is done. Now we need to run the analysis. So before running the analysis, let me show you one view which is called as extrude view. I told you previously, I'll show you that. Let me show you that now. So how to see that extrude view? So click on this set display options, and here you can see this option called extrude view here. Okay, extrude view. So check this one and then click OK. Right, nothing is visible, but you should go to 3D view. So click on 3D view. Now you will see the better view of these ones. Just zoom it. So you can see the foundation depth, and then you can see the column, and you can see the midpoint, and you can see better thing that you can see here because we have modeled the column here. Can you see the column? You can see, and the footing, foundation slab, everything that you can see. Right. So that's called as extrude view. So the same option is there even in Rivet also. The Rivet will have better option. Right. Anyway, the same option is also there in ETABS as well. Right. So now let us do the analysis part. Okay, let us do the analysis part. Just go to XY plane and then let's do the analysis. So how to run the analysis? This option is there, run analysis and design. Click on that. So once the analysis is completed, okay, now let us look for the upward soil pressure and then settlement and punching shear. So let's look at, first let us look at the upward soil pressure. So how to look at the upward soil pressure? Just click on this option, show reaction forces. Okay, load combination, soil pressure, make sure of checking all these ones, display contours, automatic, and then click apply and close. Now you can keep the cursor at the center. The value is 296. I think it has got changed. Maybe some error must have been done. Okay. Anyway, it should not be 296. It should be the same value, that is 197.73. When you are doing, you just let me know whether you will also get 296, something like that, or you are getting 197.73. Make sure of letting me know that one, because I must have selected some wrong ones and then I have looked after it. Right. So in all the section, it is showing 296. Maybe I must have selected something wrong one. So let us, you just try it out once. If you are also getting something like this, just let me know. I'll just check and I'll let you know. Right. So now let us look for the settlements. So in order to see the settlement, this option is there, show deformed shape and live load combination. Probably now we will get different values because the selection is something different. Anyway, so sorry, load combination should be dead load plus live load, and then click apply and close it. Let's see. Yeah, settlement is fine, no problem. Minus 24.71, that is fine. Now let's check the punching shear. So click on this one and you can see the value 0.603. Okay. So if you keep the cursor at the center, you can see 0.603. Why? So this should not be our value. Okay, this should not be our value. So we got punching shear as different value. Let me, right here you can see 0.487, but here it is 0.4603. Why that difference? It is because for this one, whichever we have drawn in a new one, okay, it is considering the column location as edge. That's why this difference is coming. So let us cross check. So just keep the cursor at the center and then right click and you can see the property, the location, where it is considering edge location. Codebook is fine. There is no problem with this. But column location, where it is considering edge. But where our column should be, it should be interior. Okay, it should be interior. So we have to change the point. We have to change this point to or location to interior. Right. So now what we will do is let us do that part. So let me close this dialog box. Right. So now select the midpoint. Okay. So let me zoom it and then select the midpoint. That is this one. Right. You can see 1 point selected. Okay. 1 point selected. Now, once you select this one, what we have to do is just go to design and there is this option called punching check overrides. So click on that one and a dialog box pops out. And here we have to change the location as interior. Okay. Make sure of that one. Location interior. Click OK. Click yes. That's fine. Now, one more time, you have to run the analysis. Whenever you do any changes, you have to run the analysis. Right. So the analysis is done. You can see at the bottom, it is showing ready. Right. So analysis is done. Now let's check for the punching shear. So click on this option. Now 0.5923 and here it is 0.487. So 0.5923 for newly designed footing and 0.487 for the old one. So it is almost close, 0.59 and 0.48, just 0.1 difference that doesn't influence on a large level. Okay. So now let us see the moments here. Let us see the moment. So how to check the moments? So in order to see the moments, we have this option which is called as a moment checking. Okay. So before checking the moments, maybe we can look for a couple of other options. Let me check what other options I can show here. Okay, let's look at the moments only. So select the entire footing. Okay. So show strip forces, this one. So you don't need to select, no problem. So just select this one, show strip forces. Okay. And the load combination should be dead load, factored load, moment. If you want to see along layer A, you can select that one and then click apply and you can see the moment. Now where the moment is showing, it is showing only at the center. Okay. So if you move the cursor, you will see at the other points also, but major concentration is made on the center part, this one, the stiff area. Right. So that's how you can check the moment along layer A. If you want to see along layer B also, just check this one, apply. You can see the moment along layer B also, which is around 534. Yeah, it's showing 534 something. Right. So that's how you can look for the moments value. Right. So close it. Now, whatever the value that we have calculated in the manual design, what is the value of moment in manual design? It is 594. But how much we are getting here? It is 534 something. Yeah, 534 it is, if I'm not wrong. Yeah, it's 534.443. Where it is showing? It is showing at the face of the column. Okay, we always have to look for the face of the column, right? Now, exact match cannot be found, but it's almost again the same 594 and 534, just some 60 or 50 kilonewtons of extra moment is coming. So that's fine because reinforcement will also be automatically corrected. So there won't be any problem, but exact match will never come. So between the manual calculation and the software calculation, whatever software that is, exact match will never be found. Okay, now let us do the reinforcement design. That's the last part. So the class will go for another 15 to 20 minutes. So once I complete this reinforcement design, the entire isolated square footing design will get completed. So I'll continue for 15 to 20 minutes more. So the last part is the reinforcement design part. So in order to do the reinforcement design part, here you can see one option at the top, this one. Okay, the circle. So this option is called as show undeformed shape. So click on that to see the undeformed shape. So all the results are gone. Now click on the horizontal strip. Anyone, either a vertical strip or horizontal strip. However, both we have to do. So because we have to provide the reinforcement along the length and along the width also. So select any one for time being. So click on that one. Okay, once you click on that one, you can see a green line is coming and you can see one design strip selected. Make sure of that one. So select any one strip. So currently I'll go with the horizontal one and then keep the cursor on the strip and right click. Right. So once you give right click, you can see which strip has got selected. Okay, the horizontal strip got selected. Right. So now here we need to do some changes. What is that changes? Rebar material. Okay, so rebar material we have to change. So this one, click here, you can see rebar material. So click here and then we need to select the rebar material as FE415 and then click OK and click OK. So do you want to close the form? Yes, let it close and all the results will get deleted. Click S. Right. So that's done. Now similarly, click on the vertical strip also. Okay, and then right click. And here also you have to change the rebar material as FE415. Make sure strip layer should be B. Okay, right. So that's done. So now let us run the analysis once again. So click on run analysis. Right, analysis is done. Now let us look for the factor of strip forces. So click on this option, show strip forces. So click on this one and then load combination should be factored load combination. Moment we need to check. First, let us see along layer A and then fill diagram show values. Click apply. Right. You can see the value, the strip force value, which is 534.44 kilonewtons meter. That's the moment. Okay, 534.44 kilonewtons meter. Right. So now there must be one more thing that I have to do. I have to look for the cover also. I haven't checked that one. Let me close this one. Let me do it here. So, right. So let me look for the show strip forces. Moment, that's fine. Layer, yeah, that's fine. No problem. So I'll change the cover in the later case. So you can see the moment value at face of the column is 534 kilonewtons meter. Okay, 534 kilonewtons meter. Right. So that's done. No problem with that. What is the moment that we have got in the calculation? 594. So 50 kilonewtons is change is there. So that's okay. That's not a problem. But now let us look into a couple of other aspects. That is, let me first unlock the model. So close the dialog box. Let me first unlock the model. I'll tell you the reason what I am doing in the once I complete this one. Let me first unlock the model. So click OK. But remember this value, 534 value. Okay, click OK. So let it get deleted. Now select the horizontal strip. Okay, so here I need to change the cover. I haven't changed in the previous case. Earlier only I should have done, but I haven't done. So just right click and then geometry, uh, geometry design. Let me click here. Just give me a second. So in the design tab, we have to click on FE415 and then somewhere here, yeah, this cover. Yeah, this is what we have to do. We forgot this one. I have given from preferences, but it should not be from preferences. It should be specified value. Whatever we specified, that cover it should take. So what is the cover that we have got? So we have got the cover as the effective cover or clear cover as 50 mm for footings. That's what we have considered. But we should not provide exactly this one. Why? Because we have the diameter of bar also. What is the diameter of bar? 16 mm. So how will you calculate the cover from center of the reinforcement bar? That is 50 mm plus diameter of bar divided by 2, which is 8 mm. That is 58 mm. Remember this. Don't directly consider 50 mm as your cover. You should also add the diameter of reinforcement bar. That is half of the diameter of reinforcement bar. So here the values of 54 and 54 will change it to 58 and 58. Okay. So that's the change that we have to do. Right. So once you do this one, just click OK. Okay, just click on OK and then click OK. Now similarly, you do it for the vertical one also. Right click, go to design FE415, specified from center. Here also it should be 58 and 58. Click OK, right? And then click OK, right? So now let us do the analysis. Okay, so click on run analysis. Once that is done, right? Once this is done, let us see the design of slab. Okay, so how to see the design of for the slab? So you can see this option here, which is this one. This is called as a design slab. So let me click on show design slab or show slab design, whatever that is. Right. So here you can see chip based method, that's fine. Enveloping flexural reinforcement, that's also fine. And then check minimum, impose minimum reinforcement. Whichever reinforcement that you want to see, you can check. So usually we'll go for bottom reinforcement only, not for top reinforcement. We can also go for this one. There is no problem. But let me check only one value so that we'll have the clear values. And then show total area, total rebar area for strip. This is all done. So you can check either layer A or layer B. That's completely up to you. Let me go for layer A. And then fill diagram, show values, none. That's also fine. Let it be the same. And then click apply. Apply. Right. Now you can see the reinforcement, which is 3067.912. Okay, 3067.912. But what is the value in manual calculation? It should be somewhere close to that. Let me check. Yeah, here you can see the manual calculation. We got 3174. How much we are getting in software? It's 3067. So that's almost close. There is no problem. So it is fine. So basically, this reinforcement is for the total width. Okay, this reinforcement is for the total width. Suppose if you want to see the reinforcement value or area of steel per meter. Okay, if you want to see the area of steel per meter, then you can check this option. Okay, the first one, show rebar intensity. Okay, check this one, click apply, and you can see the value 1095. So how this 1095 is coming? This is rebar intensity per area per unit width. That means what is the total area of steel? Total area of steel we got earlier as 3067. Okay, 3067, something around we got, right? Let me check that value. So total rebar, right, 3067.912. Let me keep it as 91. Right. So here, if you select this one and then click apply, now it is showing it as 1095.683. How this value has come? The total area of steel divided by the size of the footing, that is 2.8 meters. So if you solve this one, you will be getting 1095. You can cross check. Okay, you can cross check with your calculators. Right. So now let us provide the reinforcement. Okay, let us provide the reinforcement. So now what we will do is, so just check this option, show total rebar area for strip, click apply, right, that's done. So the total steel we got. So here, how much, what's the diameter of bar that we have decided? 16 mm diameter bar. So when you do 16 mm, when you provide 16 mm diameter bar, what will be the spacing value? Let us calculate. So spacing S equals to 5 by 4 into d square, that is 16 square. Okay, 5 by 4 into d square divided by total area, that is 3067.91. That's what we got, into width of the footing, that is 2800 mm, 2.8 meters. So if you solve this one, the spacing value we'll get it as 183.5 mm. Okay, this is the spacing value. Now this reinforcement, okay, whatever this reinforcement 3067 is there, that is for full width. Okay, hence we have taken the full width here. So that's the reason here. Here the reinforcement we have calculated for the total width. So is why we have to take the total width here also. Okay, if you are considering for unit width, then how to do? Same value. So 5 by 4 into 16 square divided by, what is the area when you got from here? It is 1095. That is what I remember. If I'm wrong, let me know. 1095, that is what we have got, into unit width. Unit width means 1000 mm. That is 1 meter area, 1 meter length. If you solve this one, here also you will get the same spacing. There won't be any change. 183.5 mm. So it is because we have considered the unit width. Now, in either ways, the value of spacing remains same. There won't be any problem. So here we have only one footing. But if we have a raft footing or a mat footing or mat foundation, then for every footing, we have to calculate the spacing and reinforcement. But that is complicated. Okay, for every footing, it is not possible. So to simplify this, what we can do is, we have one option which is provided by Safe Software, which is called as show total rebar area for strip. Just check this option. You can also select show rebar intensity as well, but let me go with this one. And then you can see here, typical uniform reinforcement specified below. Okay, typical uniform reinforcing, typical reinforcement it is going to show. How? What changes will come when you select this option? Let me keep the cursor here. Let me move this one. Right. So what changes that you see here when you change a couple of options here? Let us play with this one. So select this one, typical uniform reinforcing specified below. So we have to specify these values. Now, the top reinforcement bar, let it be 6. We are not going to bother about the top reinforcement. Let us bother about bottom reinforcement. So usually we are going to provide 16 mm diameter bar. So let us select 16 mm diameter bar. Now, here if you change the spacing, observe how this reinforcement will get changed. So whatever the red color line that you are seeing here, this is all reinforcement line. Okay, the reinforcement diagram it is. Observe that diagram, how it gets changed when I change the spacing. Okay, so it is 250 now. Now let me change it to 280. Let me go with, or 300 also. Let me change it to 300. Let me click apply. Now, can you see what is happening? The reinforcement is getting changed. I told you in the very first session, when you increase the reinforcement, when you increase the spacing, what will happen? The number of bars will also get reduced, or the space or the area of steel will get reduced. Let me change it to something like 200. Let us see what will happen. Now, can you see? That's how the change is. So you can see the moment graph. Sorry, this is moment graph, not the reinforcement. Reinforcement you will see at the bottom. You can see the values. Okay, 555.522 mm square, and bottom 169.95 mm square. So you can see the moment graph, which is in the red color. The size got reduced. So what is happening here? we have to minimize this size. Whatever size that you are seeing, we have to minimize this size as small as possible. Why? Because if you have moments in the section, that will cause disturbance to the element or the structure. So we should not have moments while designing the structure or while constructing the structure. If you design the structure with moments, then what will happen? Structure will get failed. So we should avoid this moment value or moment diagram as small as possible. But how to do that? You cannot reduce the spacing just like that. So you have to follow some instructions. What are those instructions? So what is the spacing that we have got here? The spacing that we have got is 150 mm center to center. So you can provide plus or minus 25 mm. That's what I told you. So either you can provide 200 or let me select 150 also. Click apply. Now can you see it completely got disappeared? Why it got disappeared? It is because we have not, there is no moment at all. Everything is good, but you cannot provide something like that. So once you calculate the spacing, your spacing value, whatever you have calculated, it should be close to that. Okay, so you can keep any value. So currently, let me keep something like 175 mm to just see that moment diagram. Right. Even now also it is showing nothing. That means it is still safe. So if you go it to 195, let's check what will happen in 195. Now you can see moment is appearing. So 175 could be the better one. Maybe 185, let us check. Right. Even what 185 also, it is very small. That's not a problem. Let me go with 175 only. Right. So there is no moment. Right. So now the last thing that we are going to look for is the number of parts. So let us find the number of parts. So in order to find the number of parts, what we have to do is we have to look for the number of parts criteria. So for that, just click on this one. I have closed the dialog box or what? Right. Let me click. Yeah. So click on this option, that is slab design. Now here you can see the bottom reinforcement is 16, and here you this one. Let me check none here. Right. So let me check none and then click apply. Let us just see the value. Right. You can see the moment diagram. Now, if you move the cursor to the face of the column, what is the reinforcement that you are getting? You are getting 3064.011. Okay, 3064.311. Right. At bottom it is. At top it is 3.061 mm square. So this is along length. So here in footing, we have provided the 16 mm diameter parts. Okay, we have provided the 16 mm diameter parts. So now what we have to do is here you can see show number of bars of size. Select this option. Okay, select this option. And here we have to give the diameter of bar. So what is the diameter of bar? 16 mm. So top bar, you can give any value. Currently, we are focusing on bottom bars. So give 16 and then click apply. Right. Now, can you see the number of bars? Is it showing directly? 16-16. What does it mean? 16 mm diameter bars. Okay, 16 mm diameter, 16 mm bars of how many numbers? 16 numbers. So it is directly telling the value. You don't need to calculate anything. So first value is actually the diameter of bars. The second value is basically the number of bars. Okay, so this is along length of the footing. So we have provided along length of the footing. What is the spacing that we have provided? 175 mm. So if you want to see along width of the footing, then you select layer B and then click apply. So here also you can see along width, what is the value? So here also it is 16-16. That is 16 mm diameter bars with 16 numbers or for 16 numbers. Now let us look for one-way shear. That's the last part. Okay, one-way shear we haven't looked for. So one-way shear we have to look for. Right. So now just unlock the model. So let me close it. Unlock the model. Right. Click OK. Right. That's done. So now let us draw points. Okay, let us draw points. So draw, go to draw points. And once you get this dialog box, just type object, its point, and then X. This is where we have to look for. So one-way shear acts at a distance D from face of the column. So if you remember, one-way shear will act at a distance D from face of the column. Let me draw it properly. Just give me a second. Right. So this is our footing, and inside this we have the column. and we know that act at a distance d from face of the column. If you make it a straight line here, so this is at a distance d. Okay, this is where one-way shear will be acting. Now we need to find this length. Okay, we need to find this length. So whatever is this length, okay, whatever is this length, the same length that we have to give it there. I'll tell you what is that. So here, so how to get this length? So the total length of the footing is 2.8 meters. Width of the column is 0.4 meters. So 2.8 minus 0.4 divided by 2. This will be divided by 2 minus this distance d. Okay, minus d. So 2.8 minus 0.4 is 2.4. 2.4 divided by 2 is 1.2 minus d. What is the effective depth of the column? 0.542. Okay, 542 mm. So how we are getting 542 mm? The overall depth of the column, the overall depth is 600 mm minus clear cover, that is 50 mm, minus diameter of bar divided by 2, that is 16 divided by 2, which will be 542 mm. Okay, remember these values. So I remembered, so I am directly telling the values. So 0.542 mm. So 1.2 minus 0.542 will be 0.658 meters. Remember this one, 0.658 meters. Now, how will you calculate shear? Upward soil pressure. So to calculate shear, V equals to upward soil pressure. What is upward soil pressure? Let me check the value. It is something 197 something. I think 197 only we got, as far as I remember. Yeah, it's 197 only. So upward soil pressure equals to 197. Okay, 197 into this distance, that is 0.658. 0.658 into the width of the footing, that is 2.8 meters. So if you solve this one, you will be getting the value as 362.9 kilonewtons. This is the shear force, but we need to calculate the ultimate shear force, VU value. 1.5 times of 362 will be 544 kilonewtons. This is the ultimate shear force. Okay, remember this. This is the ultimate shear force. Now here, in the d value, so here plan offset, okay, or point x, here we should give the value as d value. What is d value? 0.542. Okay, 0.542 meters. Remember this value, 544 is the value. Remember that. I'll erase all these things. So here, let me give the value as plan offset x is 0.542. Okay, so that's d from d value of shear. Okay, remember that. That's the depth of the footing also, you can say, right? So a y value is 0. Now, just move the cursor to the center of vertical line, any vertical line. Okay, move the cursor to the center of vertical line. Okay, you can see here, any vertical line, either the left side or the right side, and then click there. Right, can you see the point that is coming? This is our shear point area. Okay, so that means somewhere here, the distance d from face of the column. This is our area. Okay, so this is our one-way shear zone. Okay, this is the one-way shear zone. Now, this is where we have to look for shear values. Okay, in this zone only, we have to look for shear values. So how to look for that? Just close the dialog box. Now, let me run the analysis. So click run analysis, right? Once that is done, now let's look for one-way shear value. So to look for one-way, to look after one-way shear value, here you can see one option which is called as show strip forces. Okay, click on this one, show strip forces, and here we need to look for the load combination as 1.5 dead load, live load, and here shear force. Okay, earlier we have looked for moment. Now let's look for shear force. Similarly, you can look for torsion and axial shear force also. Okay, you can check that when you are practicing. So check shear force, and then tip layer should be A or B, anything is okay. Click apply. Okay, you see 447.02. Okay, 447.02. But in manual, how much we got? We have got one-way shear. Let me check that. Yeah, 542 we have got. So 447, 542. It's again, you cannot see exact software value, or I mean, you cannot get the exact values, but it's fine. There won't be any much problem, because settlement is fine, to punching shear is fine, and then upward soil pressure is also fine. So there won't be any problem with this. So that's how you can design the isolated square footing. So this is all about design of isolated square footing. So if you want to look for along layer B also, click apply and then close. You can see 447. That's fine, no problem. Okay. So that is all about the design of isolated square footing. So in the next session, we are going to look for the second footing design, which is called as isolated rectangular footing. Right. So that's from my end for this particular session.